So far we've only learned about two angles, whether they exist inside or on the circle. We've learned about central angles, where their vertex is on the center of the circle, and the central angle has the same measure as the arc it intercepts. And we've learned about inscribed angles, where the vertex of the angle is on the circle, and it is going to be half of the arc. The newest property that we're going to learn is when one of the angles exists inside the circle, but it's not in the center of the circle. And that's when you have two secants that intersect inside a circle. When the two secants intersect inside the circle, the angles that they form are very similar to the midpoint of the circle. We basically do the midpoint formula, but we use the arcs as our two values in the midpoint formula. So the easy formula is you have arc plus arc divided by 2, and it equals the angle. And in this diagram, you'd have arc DE plus arc AB divided by 2, and it equals angle 1. So for the first example, we want to find x. So the x is inside the circle, formed by two chords, which if extended they would be secants, and the angle is inside the circle. So we would take the arc plus the arc, meaning the two arcs that form the angle, and divide by 2, and that'll give us x. So we take 84, add it to 130, divide that quantity by 2, and that equals 214, which we will divide by 2, which gives us x, which is a total of 107. Okay, so I'd like you to try the next example on your own. This time the angle in the middle is, or the angle inside the circle is given to us. So you're going to substitute the values that you know into this formula, and you'll have to work backwards in order to get x. So pause the video and see if you get what I get. Okay, you should have gotten x is 123. If you didn't and you're not sure how to get that, raise your hand. Okay, the next property of angle measures that exist in circles is when you have a secant and a tangent. Okay, and these aren't anything different than inscribed angles. They're going to be angles that exist with the vertex on the circle, and they're going to have a measure that is half of the arc that surrounds them. So, for example, angle 2, or we'll go with angle 1, the measure of angle 1 would be arc BA divided by 2, just like an inscribed. This angle is half the arc. And the measure of angle 2 will be half of arc BCA. Okay, so for the first example, we have QPR. So angle QPR, the arc that represents it is 148. So angle QPR would be half of 148. So the measure of angle QPR would be 74. Okay, so in order to find DEF in the next example, you're first going to have to find arc FD, and then behind the idea that a circle has 360 degrees, you can find FED. So I'd like for you to pause the video and see if you get what I get. Okay, so you should have gotten the measure of arc DEF is 232. If you didn't and you're not sure how to get it, either ask a neighbor or myself. The next angle measure is formed with two secants. And with two secants, the angle that we're looking for is going to be outside the circle. When you have an angle that is outside the circle, it's going to be a subtraction problem. So the way I think about it is like money out of your pockets. You're taking away from what you had in your pockets. You're subtracting. So when the angle exists outside the circle, it's going to be a subtraction problem. So you'll take the two arcs that are intercepted, arc DE, and you'll subtract them. Make sure you subtract the larger arc from the smaller arc. Subtract the smaller arc from the larger arc. And you're going to divide by 2. That'll give you the measure of the angle that's outside the circle. So the measure of angle A. So arc minus arc divided by 2 equals your angle. So the first example, we have the angle is formed by two secants, and it is outside the circle. So just like money out of your pockets, we're going to subtract. In this problem, we're going to take away the money that's inside your pockets, and we're going to do that by taking the large arc minus the small arc, dividing by 2, and that'll give us the outside angle, which is 25 degrees. So you'll get 110 minus x equals 50. So we would subtract 110 from both sides of our equation. So we get negative x equals negative 60. So that means a positive x would be positive 60. Alright, so I'd like for you to pause the video and try the next example on your own. We're looking for the measure of angle H, which is an outside angle. And you should have gotten the measure of angle H is 31 degrees. If you didn't, ask a neighbor or raise your hand. Okay, the next angle is also an outside angle, and that's formed when you have a secant and a tangent. It's going to be the same thing. You take the two arcs that are intercepted by the secant and the tangent, and you subtract them. So once again, the angle is outside the circle. So when money is out of your pockets, it's been taken away from you, so it's a subtraction problem. So you're going to take arc DC and subtract arc BC, divide by 2, and that'll equal your outside angle, which in this case is angle A. So the simple version is arc minus arc divided by 2 equals your outside angle. Okay, so to find the measure of arc LP, we'll call it x in this problem since we don't already have an x. Same thing. Big arc minus the little arc divided by 2 equals the outside angle, which is 36. So cross multiplying here, we have 72 equals x minus 78. Adding 78 to both sides, we get x equals 150. Which was the measure of LP. So the measure of arc LP is 150 degrees. Okay, so same concept. I'd like for you to try the next example, finding the measure of arc QTS. Once again, I'd start by calling it x and using the formula. Pause the video and see if you get what I get. Okay, and you should have gotten the measure of arc QTS is 248 degrees. Okay, and the last angle measure that's formed with two tangents will once again be outside the circle. And there's two concepts behind this one. The first one we already know, and that's that measure of arc BDC plus the measure of arc BC form the circle. So they have a sum of 360 degrees. So this arc plus this arc make up the whole circle. They equal 360. That's pretty easy. And then next theorem is that the little arc and the exterior angle outside the circle are going to be supplementary. So the measure of arc BC plus the measure of angle A is 180 degrees. So the first example for that is to find measure of angle W. So all you need to know is that the little arc and this angle equal 180 degrees. So we would take 180, subtract 106, which will give us the measure of angle W, which is a total of 74. Alright, I'd like for you to try the last example on your own and see if you get what I get. Remember, it's this arc and this angle that equal 360, or sorry, that equal 180. But you'll use this first formula to find the missing part of the arc. Okay, and you should have gotten x is 110 degrees. Alright, I'd like for you to try the following examples on your own. I'm just going to have you pause the video and then unpause it to see if you get what I get. Okay, so the measure of angle 1 is 45 degrees and the measure of angle 2 is 135. For number 2, pause the video. And x equals 40. We should be looking at our theorems and formulas up above. Number 3, pause the video. Should have gotten that x is 43. And then finally 4, pause the video. Number 4 should have been the measure of angle A is 81